Here we're asked to write the following as a sum of partial fractions. What that means is to do the opposite of what we did in the get ready. In the get ready, we had two fractions that we added together to get a single fraction. Here we're going to break it apart again. So we've got the single fraction and we want to split it back up into the two fractions we added to get it. And the reason we do this is when we get to integration, it's a really powerful technique for simplifying fractions to make it easier to deal with. But let's for now just look at how we do it. So the first thing is we're going to factorize our denominator. Factorizing the denominator here, we're going to get 3 and 2. It's plus 3 and minus 2. What that means is that this could be written as a sum, which was some value a over x minus 2 plus some other value b over x plus 3. Now, if we had to add these two together, we would get something like this. And actually, that's the next step. What we do next is we add these together. What would the common denominator be? The common denominator would be x minus 2, x plus 3. So now we're using those skills of working with algebraic fractions. We multiplied x minus 2, we multiplied by x plus 3, so we have to multiply the numerator by x plus 3. Here we multiplied the denominator by x minus 2, so we need to multiply the numerator by x minus 2. Expanding and combining, we're going to get ax plus 3a plus bx minus 2b all over x minus 2, x plus 3. Now, the important thing here is that we have ax plus bx, and that's the only way we can get x's out of this expansion. And we know that that has to be equal to 7x. So that means that a plus b has to be equal to 7. We also know that 3a minus 2b is the only way we're going to get some number out of this, and we know that that has to be equal to plus 1. So we know that 3a minus 2b has to be equal to 1. And this gives us a pair of simultaneous equations to solve, which we can either solve in our calculator or manually. Let's do it, we'll do it in our calculator. That's fine for this. When we do that, we get the values that are a is equal to 3 and b is equal to 4. 3 plus 4 is 7. 3 times 3 is 9, minus 2 times 4, which is 8, so 9 minus 8 is indeed equal to 1. To verify that quickly, I work this out on my calculator, and what that means is that this original fraction that we had is equal to this thing, but with these values of a and b. So 3 over x minus 2 plus 4 over x plus 3. And that is how we decompose a algebraic fraction into the partial fractions. We set it up with the denominators we know have to be there, but with unknown numerators, and then by equating these two expressions, we can solve them simultaneously to find the values of a and b.